Hello, in this video we are going to go over the solution of the problem 542-01 matrix, and we are going to use the data structure BFS. Imagine that we are given a matrix like this one and we want to know how 0 could influence the ones in this matrix. For example, the resulting matrix should be something like this. If we consider this cell 3, I need 3 steps from 0 to walk through 3, or 5, I need 5 steps. Okay, let's start writing the code. To write the code, first I'm going to define the number of rows with capital R and number of columns with capital C. Then I'm going to add all of the zeros in the matrix to a queue. For doing that, I have already imported dq from collections, and I just need to define an empty queue. Okay. Also, I'm going to keep track of the visited nodes, so I'm going to define an empty set called scene. Now we can make a for loop for R row in enumerate grid, for column index value in enumerate row. If val equals 0, we add that to our queue. We say queue dot append rc. I'm going to put a timer here at 0. Also, we say scene dot add rc. Okay, we have all of the zeros added to our queue. Next, we have a while loop, and I say rcd equals q dot pop left, and then I'm going to search around row and columns and say for nr neighboring r neighboring column in 4 directions around that, vertical and horizontal. If nr is in the bounding of the matrix and nc similar, and grid of nr nc equals what? Equals 1, because when it is 1 I can walk over that, and nr nc not in scene. See, if it is not visited already. In that case, we update the grid value by saying grid nr nc equals d plus 1, because I want to know the distance from 0 and update the grid value to that. Okay, and then I append that to my queue. Append nr nc d plus 1. We update our timer. Also, we update our scene. Okay, that's it. Now we just return updated grid and the distance d. Okay, I'm getting an error. Why is that? Oh, I forgot 0 here. Okay, perfect. So we got the result as this one. So for the first row is 0, 1, 2, 3, and the last row you see 2, 3, 4, 5, and I need 5 steps to visit all of the nodes. So the time complexity of this solution is order of n, because we are visiting each node only once. N is just number of cells, and the space complexity as we are building this queue and also scene, it's also order of n, because in a worst case scenario queue could be very large, but it's never going to be more than n. Okay, so this is the solution of the problem 542, and thank you so much for watching this video.